Okie doke. This video we're going to go over slope from a graph. And I will be honest, I'm pre-recording this video and have no idea what page number it's going to be in our binder. I do know that these are the notes that we're using in the 2022 to 2023 school year though. I think it's going to be page 22. Okay, so slope and rate of change. In 7th grade, you guys learned what rate of change was. You learned unit rate in 6th grade and expanded upon that 6th grade unit rate. Learned rate of change in 7th grade. In 8th grade, we're going to introduce this word slope, which really is just the same thing as rate of change. They're the same. So we can use them interchangeably. All of that is also the same as your unit rate. And another way to say this is the constant of proportionality. Constant of proportionality. You only use that in proportional relationships though. Proportionality. Okay, the letters that we use to represent slope or constant of proportionality or rate of change or unit rate are M, A, or K. Those are our common letters. Okay, slope is the rate of change in a relationship. Slope or rate of change is the ratio of the change in the y variable. The y variable is dependent. Over, that's just fancy division, the change in the x variable, which is the independent variable. So another way we can write this triangle symbol in math is called delta, and it means change. So we can say that's the change in y over the change in x. And we actually can also, we call commonly the change in y. Y is the axis that goes up and down. So we call this rise over, x is the axis that goes side to side. We often call this rise over run. What I want us to get in the habit of is writing a plus or a minus and then rise over run. The plus or the minus will just tell you if the slope was positive or negative. Okay, looking at the different types of slope. So the way we determine what we get, I'll name the types of slope first actually. Okay, so we've got a positive slope if the slope increases from left to right. So if you point your pencil to the right and then lay it on the line, if the pencil goes up, the slope would be positive. However, if the pencil goes down, it would be decreasing from left to right. From left to right. So if your pencil goes down, then you have a negative slope. Okay. A horizontal slope is one that goes side to side, but not up and down. If it's going side to side, then that means there's no rise. So that would be 0 as the rise, and the run would be some number. Maybe it'd be 5. I don't know. There's a number there. Anyways, 0 divided by anything in the whole wide world is still 0. So a horizontal line has a 0 slope. The way I remember that is the sideways line. I put a sideways line through my Z's so they don't look like 2's usually, but so that's how I remember that it's a horizontal line. Another one, you can make a Z. You can make a Z using the 0 line, the 0 slope there. Okay. Now we've got the last one is an undefined slope. Undefined slope is for vertical lines. Undefined. Okay, this one goes up and down, so its rise up and down is a number, but it's not going side to side at all, so it doesn't have a run, or its run is 0. That would be a number divided by 0. Well, in math, it's illegal to divide by 0. You can't divide by 0. So there's no number in the world that we know of that defines a number divided by 0. So this is an undefined line. Okay, so those are the 4 different types of slope we're working with. And what we're going to do in this next little portion is just identify which lines are positive, which ones are negative, which ones are undefined, and which ones are 0. I like to remember the undefined line because using the undefined line I can make a U. Okay. Right, let's look at line A in this next part. Line A is the one that's going side to side. It's a horizontal line. Line A is going side to side, and I can draw the Z on the side to side line, so I know that this is 0. Line A has a 0 slope. Line B is this line here. And if I put my pencil on this line so it's pointing to the right, I see that this is pointing down. So since this is pointing down, I know that this is a negative slope. Looking at line C, line C is going straight up and down. And I know that with straight up and down lines, I can draw the U. Since I can draw the U, it's a straight up and down line. Vertical lines have a slope of, what's an undefined slope? Okay, and then line D, going from left to right, line D is pointing up. Since it's pointing up, line D is positive. Okay, so what's a strategy that we are using to help us remember an undefined slope and a 0 slope? I'm going back and forth on this color coding and it's driving me nuts. Okay, an undefined slope, remember, is something that goes up and down. I like to remember that because I can make the U with the in the word undefined line up with the actual vertical line. Okay, and then the 0 slope goes side to side, it's horizontal. And the way I like to remember that is I can make the word 0 line up with the line there. We can see that this matches that and this matches with that. So now let's put this to use. Now we for sure know when the slope is 0 and undefined, and then I can also tell you if it's a positive or a negative slope. And we kind of know at least what slope means. It's rise over run, that's the change in how far up and down and how far side to side. It's the ratio between the up and down change and the side to side change. So some more pro tips on finding slope from a graph. We've got to find the value of slope from a graph, find the ratio of the vertical change compared to the horizontal change, or rise over run. Rise would be your vertical change, that's your change in y, and run would be your horizontal change, that's your change in x. To do this, we're going to choose any 2 points on a graphed line, and then we're going to draw a right triangle with those 2 points to count the rise and the run. We're always going to simplify the ratio when possible. And remember to check if the slope has a positive or a negative slope. or 0 or undefined. Okay. So we'll look at this example that they have right here. They've already labeled the 2 points. So they've chosen the 2 points for us on the graphed line. They chose this point and this point. Okay. After that, they drew the right triangle between the 2 points. That's this line. They drew the rise, and then they outlined the run to make that right triangle that falls on the line. Okay. And now we're just going to count the rise and the run. I'll count the rise, which is this piece, and then I'll count the run, which is this piece. Okay, so the rise, which I've got going on in green, the rise is going from this line up to this line. That's 1, 2, 3, 4. So the rise of the graph is 4, and the run of the graph, so the side to side change, that's going from here to here, is 1, 2, 3. Okay, so the slope has to be positive or negative, or undefined or 0, rise over run. Okay, if I had a pencil and I pointed my pencil towards the right, it would go pointing upwards. So this is a positive slope, and we counted that the rise was 4 and that the run was 3. That's supposed to be the blue. So the slope of this graph is positive 4/3. Now we're going to look at the remaining graphs below. Okay. So in this first example, they've chosen the 2 points for us. They've marked our 2, I like to call them perfect points. They're just the 2 points that fall on crosshairs. A crosshair is when the 2 lines cross each other. The crosshair is right there. It's like X marks the spot or hitting the target. Those are some other ways people have referred to that. So it rises the, I've got my 2 points marked. Now we need to draw the right triangle between them. So I'm going to pick one of them, and I'm going to pick this point, and I'm going to draw it going up. And then I'm picking the other one to close the right triangle. I have to draw this line going towards the left. And now I've got the right triangle. So I've got the right triangle, I'll color it in. There's my right triangle, okay? The rise goes from here to here. The rise is 1 box. 1 box is going from 2 to 3, which is really a difference of 1. So I know that the rise is 1. Now I'm going to look at the run. The run goes from this point to this point. That's the sideways line. And it goes over 1, 2, 3, 4 lines. And that goes from 4 to 8. So that really is a difference of 4. So the run is 4. So it looks like I've got a rise of 1 and a run of 4. Now I just need to use slope as positive or negative, rise over run. The right arrow points going up, so this is a positive, and then rise is 1, run is 4. So the slope is positive 1 over 4. Okay. Looking at the second example, now we have to pick our own 2 points. They don't have those labeled for us anymore. I see there's a ordered pair at 0, 7. I see a point at 0, 7. And I see another point at 4, 5. there's more points. There's one at 2, 6, and at 6, 4, and at 8, 3. Right, there's other points. It doesn't matter which two you use. You've got to pick 2 of them to use. Okay, so now I'm going to draw a right triangle that lies on this line. So I'm going to use the 0, 7 we had. 0, 7. And I'm drawing it sideways towards the right, and then the line that comes out of 4, 5, to meet that line and close the triangle, would have to go up. Okay, so now I've got a right triangle here. Remember, slope is positive or negative, rise over run. If I were to put my pencil on this line and make it so it's I've got my pencil pointing to the right, and I put it on this line, it would point down, so I know the slope is negative. Now the rise is the edge of the right triangle that's going up and down, so that's this piece right here. That's 1, 2, 3. I was going from here to here, which is just 3. So the rise is 3, and now I'm looking for the run. That's going side to side. That's from here to here. That is 1, 2, 3, 4, 5, 6. The run is 6. So we've got negative 3 over 6. 3 over 6 can be reduced. We've got negative 3 over 6. That can be reduced. That's the same as negative 1/2. So the slope is, you could use negative 3 over 6. That's equivalent to the same fraction that the slope is. We want to reduce it. That way we're using smaller numbers in our fractions. So the slope is negative 1/2. Looking at the next one, we have to be really careful with graphs that have scales. So what I notice about this graph is that when we're going up and down, it's not counting by 1s, it's counting by 3s. So that's going to heavily affect our rise when we count up and down, because when we're counting up and down, now going up 1 box isn't going up 1, it's going up 3. Before we even do that though, we've got to pick 2 good ordered pairs. I see an ordered pair at 2, 9. I see an ordered pair at 2, 9. And I see an ordered pair at 4, 18. So I've got one at 2, 9 and at 4, 18. Now we'll just draw the right triangle that connects, that falls on this line connecting those 2 dots. So out of 2, 9, I'm going to draw a line going to the right. And then out of the other dot, 4, 18, to make that close the triangle, it's going to have to go down. Okay. And now I've got the right triangle that lies on the line, so I'm ready to find the rise over the run. We know that slope is positive or negative, rise over run. Okay, if we had a pencil and we made it point to the right and then put it on this line, it would go up, so this line is positive. Well, the slope is positive, sorry. This line has a positive slope. Okay. So now I'm counting the rise. The rise is the up and down leg of this right triangle, and that's 1, 2, 3 boxes. But each of those boxes really counting by 3. So this isn't just 3, this is 3 and then 6 and then 9. So when you've got a scale, you can take the number of boxes that you were counting, which was 3, and multiply it by whatever the scale is. In this case, it was also 3. 3 by 3 is 9. So the rise is 9, and then the run, I'm looking at my graph scale on the bottom, or on the x-axis, and it is counting by 1s. So I'm not going to have to remember to count by anything specific. So on the run, I'm going from 2 to 4. That's just 2 boxes, which is really just the number 2. So the rise is 9 and the run is 2. So now I have my slope, which was positive 9/2. So the slope is positive 9/2. Okay. I'm looking at The next problem, we've got a graph with all 4 quadrants here. So we're going to want to pick 2 ordered pairs that are on the line. I see one at 0, 0, the origin. I see one at 3, 4, and there's also one at 3, negative 4. Any of those points are fine to use. We just have to pick 2 of them. I'm going to pick to use negative 3, negative 4, and 0, 0. Okay. So now we have to draw the right triangle that falls on this line connecting those 2 points. So out of negative 3, negative 4, to get to the other dot, I either go up or I go to the right. I'm going to go up. And then out of the origin, to make that right triangle closed, I have to go to the left. And now I've got my right triangle that's on this line connecting those 2 dots. From here, I just have to count the rise over the run because I know slope is positive or negative rise over run. Okay. If I had my pencil with me, and I could show you on the screen, then I'd have my pencil so it's pointing to the right, and then I would put my pencil on the line, and my pencil would point going to the right, it would point up. So I know that this is a positive slope, and now I'm counting the rise. So the up and down line is 1, 2, 3, 4 boxes. Going up 4 times really is a change of 4 because the up and down axis, the y-axis, has a scale of 1. So if I count up 4, that's really actually 4. And then the x-axis has a scale of 1 as well. So when I count the run, I don't have to remember to multiply at the end or count by a certain number. None of that has to apply here. So that's a difference of 1, 2, there's 3 boxes in between them. And you can go back to the origin. If you count 3 boxes over, you see the number 3. So that's another way I can check that my x-axis had a scale of 1. Okay, since 4/3 can't be reduced, I know that I can say that the slope, or the letter m, is positive 4/3. The next line is a vertical line, and vertical lines match up with the letter U for undefined. So I know that this slope, or m, is undefined. Okay, mathematically, a way we can see that, if we pick any 2 good points on this line, there's 1, there's 1. It's impossible to draw a right triangle here. So let's pretend that we didn't draw the right triangle because it's impossible, but we're still going to continue on with this in the hard task, difficult task of finding what this slope of this line is. So we've got positive or negative, and we're not really sure because if I put my pencil toward the right, it doesn't point up or down. So I'm not sure if it's positive or negative, but I'm still going to go on and find rise over run because I still don't know that this should be undefined or 0 yet. The rise that I've drawn here is 2, and the run is 0. That's the same as 2 divided by 0, but we can't divide by 0 in math. That's illegal because that number is not defined. So since there's nothing to define a number divided by 0, the slope has to be undefined. So there's a lot of hints when you have your vertical or horizontal lines that the answer isn't a number and it's not a ratio. It's going to be 0 or undefined. One of those hints was when I plotted my 2 points, I couldn't draw the right triangle. There wasn't a way to draw a right triangle between the 2 points that fell on the line without making diagonal lines. The next was when I pointed my pencil towards the right, I didn't know if it was positive or negative because it didn't go up or down. It didn't go to the right at all. Okay. Looking at the very last problem on this page, number 7, picking 2 good points. I see a ton of good points on this line. There's one at the origin, there's one at -3, 6, there's one at 2, -4. There's all sorts of points on this line. You just need any 2. I'm actually going to use the point at 2, -4 and the point at let's see, 3, -6. Okay, so if I'm at the point 2, -4, and I want to go to the point at 3, -6, I either have to go down or I have to go to the right. I'm going to pick to go to the right. And then to make the other point, 3, -6, close that triangle, it has to go up. So now I've got a right triangle that's on this line that connects my 2 dots, and I didn't have to draw anything diagonally. I was able to just draw left or right lines on my graph. Okay, the rise is 1 box, and I'm looking at my graph. Oops, rise is 1 box, but 1 box going up and down really represents the number 2. So a change of 1 line is the same as saying that the change is 2. So the rise is 2, and then the run goes from here to here. That's also a difference of just 1 line. Going side to side, the scale is counting by 1s, so a change of 1 line is 1. Okay. The only thing I forgot was to look at the arrow out of the line on the right side. So on the arrow out of the right side, on the line out of the right side, the arrow points down. If you had your pencil and you pointed it to the right and then you laid it on this line, your pencil would point down. So this is a negative slope. So I'm setting this up, positive or negative rise over run. We have a negative slope. The rise was 2. The run was 1. And we know that 2 over 1 is the same as 2. So the slope of this line is -2. There's one thing I want to mention that I don't think this did. Go back to the very front of your page, so where we started taking notes. Yeah, okay, slope measures the steepness of a line. The steepness of a line. So how fun is it to ride my bike down that hill, or how hard am I having to work going up this hill? It is not the distance. It is not telling us how long the line is. And that's really evident looking at the 0 box or the undefined box, right? This line clearly has a distance of something. So its distance or length couldn't be 0. That's just telling you that when you ride your bike on this, it's not hard work because it's flat, but it's also not fun. Same thing for undefined. This has a length, so I can't say that the length is undefined. It's just, I don't know if that's going to be hard work or easy work, right? I don't know if I'm climbing straight up that hill or if I'm climbing straight down that hill. Either way, it's probably scary. And then on your positive slope, it's really hard to go up that line, that slope, because you're bicycling up the hill. And then the negative slopes are really fun because you get to ride down the hill. This video is over slope on a graph. If you have questions, comments, concerns, please don't hesitate to reach out to me via Schoology, email, or your parents know how to get in contact with me in other ways.